You know that feeling when the sink at home starts draining slowly? It's annoying, right? Well, imagine that same problem, but at a massive food processing plant or a hospital. All of a sudden, it's not just annoying, it's a potential catastrophe. That's a whole different world. So today, we're going to dive into the highly specialized engineering that keeps these absolutely critical systems flowing.
All right, so here's our game plan. First up, we'll talk about why these systems are so much more than just a simple drain. Then we'll get into how they're actually designed for the challenge. We'll also look at some clever ways to stop problems right at the source, see how maintenance is key to performance, and finally, explore how you can turn what seems like a risk into a real business asset.
Okay, let's start with a really crucial point. An industrial drain is not just a supersized version of what's under your kitchen sink. Not even close. The scale, the stuff that goes down it, and the stakes involved, well, they're in a completely different league. And this slide really puts it all into perspective. Your drain at home deals with what? Soap, some hair, maybe a little food waste. An industrial drain, on the other hand, is basically a war zone. It's fighting a constant battle against heavy gunk, corrosive chemicals, and a relentless nonstop flow of fats, oils, and grease. It is literally built for abuse.
This really gets to the heart of why businesses invest so much in these systems. See, it's not just about avoiding a clog. It's about preventing catastrophic downtime, dodging massive emergency repair bills, and staying on the right side of some very strict regulations. The cost of failure is just way too high.
So if the problem is that complex, you can bet the solution has to be just as sophisticated. And that brings us to the design phase, where these drainage systems are engineered with almost surgical precision for a very specific purpose.
You know, you can't design a solution if you don't really truly understand the problem. That's why it all starts with a deep analysis. What exactly is going down this drain? Is it greasy solids from a giant commercial kitchen, or is it corrosive discharge from a manufacturing plant? The chemistry of that wastewater dictates the entire design.
And the process is super methodical. First, you analyze the waste stream. Then, you calculate the volume, how much is flowing, and when are the peak rush hour times. Based on all that data, you select materials that can actually withstand that abuse. And only then do you engineer the physical layout of the pipes to make sure it all flows just right.
And let me tell you, the details matter immensely. We're talking about getting the slope of the pipe just right so gravity does the heavy lifting. Using bigger, wider pipes in key areas to handle high volume. Designing the junctions and connections so they don't become little collection points for debris. And using specialized materials and liners that can resist chemical attacks. Every single choice is deliberate.
Now, even if you have the most perfect design in the world, it's always smarter to stop problems before they even get into the system. This brings us to a really powerful concept, interception. It's all about catching the bad stuff right at the source.
A perfect example of this is a grease interceptor. You'll find one in pretty much any commercial kitchen. It's a simple idea, but it's totally brilliant. It's basically a holding tank that cools down hot, greasy water. This allows the grease and oil to float to the top and the solids to sink to the bottom. So what flows out into the main sewer lines is much, much cleaner water.
And the impact of this is enormous. By trapping that grease right at the very start, you dramatically reduce the risk of those awful concrete-like blockages from forming deep inside the plumbing network. It is a classic case of an ounce of prevention being worth a pound of cure.
And this strategy isn't just for grease. For sites that deal with a lot of grit or sand, you can use separators to pull out those heavy solids. For facilities with chemical discharge, there are pretreatment systems that can neutralize harmful stuff to make sure they're meeting all the regulations before the water even leaves the property.
Okay, so you've got a great design and smart interception, but these systems are working 24/7 and they need ongoing care. This is where the whole philosophy shifts from just waiting for a disaster to happen to proactively making sure one never does.
But that raises a pretty obvious question, right? I mean, how on earth can you know what's going on inside miles and miles of pipe that are buried deep underground? You can't just dig everything up to take a peek.
The answer is technology. Modern maintenance is all about sending high-def cameras deep into the system. These CCTV inspections are like giving the pipes a full medical checkup. They allow technicians to spot tiny little cracks, invading tree roots, or corrosion long before they cause a complete and catastrophic failure. This data-driven approach allows for really intelligent maintenance. So instead of that panicked emergency call at 3 a.m., cleaning gets scheduled during planned downtime. This proactive cleaning removes buildup methodically, which minimizes disruption and keeps the business up and running. So let's bring this all together. When you combine that smart design,
the interception, and the proactive maintenance, you fundamentally change the role of a drainage system. It stops being this constant source of worry and risk.
And for so many critical industries, this is absolutely non-negotiable. Think about it. A hospital or a massive food distribution hub. They simply cannot afford to have their entire operation shut down by a preventable plumbing problem. Reliability is everything.
This whole thing really comes down to two different mindsets. You've got the old, reactive way, which means unpredictable emergency costs, catastrophic downtime, and a much shorter lifespan for your whole infrastructure. Then you have the new, proactive way, and that turns everything around. Costs are predictable and budgeted, downtime is minimal and scheduled, and the system's lifespan is dramatically extended.
And this is the ultimate takeaway. By layering these three strategies, specialized design, targeted interception, and data-informed inspection, what was once a huge operational risk becomes something else entirely, a manageable, reliable, and even measurable asset that supports the business.
So it leaves us with one final thought. Whether we're talking about a large-scale industrial facility or any critical operation, it's worth asking, is your drainage system an unpredictable liability just waiting to fail, or is it a well-managed asset you can actually count on?